Alright, it's because the other video that I captured kind of dropped the end of it, the end of the solution here. I kind of start from like a few minutes before that video, essentially trying to plot this moment for the moment diagram. What we got, I have put here. This was the shear force function for the left hand side. This was for the right hand side. This here, I plotted them, right? That was what it means. And then on the other hand, we introduced this important equation that essentially saying if I have these two functions, I can integrate them and then find the moment. So for the left hand side, I have it here. Note that this equation is popping right there, and I'm integrating it. After integration, I ended up with this guy, with the C naught over there. In order to find that constant, I come here, I'm like, what do I know? I know that at x equal to 0, it means that point in my graph, I don't have any external moment or any moment. So moment should be 0. So that's one point that already shows. Also, C naught is 0. So I put C naught 0 and write my equation there nicely so I can plot it. Well, how do I plot it? Well, I find 2 points in it. One point is right there, and the second point I chose to find at x equal to L over 2. So at this point, I find my v, which turned out to be this magnitude, W naught L over L2. I'll put it right in here, so maybe somewhere right there. It is W naught L2 over 12, right there, at this point. So that would be my second point. Okay. Essentially what we're doing right there is finding the integral of this curve, right? So whenever I tell you, this is like the point which is important. So whenever you see, even like from this left hand side, right, you can immediately say that when they ask you what is the maximum or minimum, for example, of your moment along your beam, where is the location of it? Alright, let me show you this very quickly, maybe right here from your math classes. Well, look at this guy, this function, right? What I want to say, so imagine if dm over dx is equal to 0. This what does it mean? It means that v is 0, right? Do you remember the derivative of a function when you say it's equal to 0? That is essentially telling you, and if you solve this and you find the x, it's essentially telling you where the location of the optimum point of your function is. That is, well, by optimum I mean either maximum or minimum. Okay, what is it in there for you to use? You come over here, wherever, like on your shear diagram, as you plot your shear diagram, it's possible that it's actually passing through a point, passing essentially from your x line, right? Means it turns into a 0 at point. That point, where in this case is at x equal to L over 2 in the middle, that is where your maximum or minimum is located. It's really important. It means that if they are asking for the maximum, and I come over here, I'm like, if as soon as I find this number, which I found, that is my maximum moment. Maybe you don't even need to plot all these curves, right? Okay, if for example, in another case, if I had two, for some reason the curvature was such that, I don't know, somehow it would pass at 2 points, you have to come over here and plot your moment diagram and find the magnitude of moment corresponding to these 2 points. The magnitude of those 2 points that you're seeking for is going to tell you those points are at actually the peak or minimum location, okay, of a moment. Then you compare those to maximum, and then you find the maximum of the maximum, essentially, if the question is asking you that. All right, let's clean some of this board. Which is not working apparently. Well, is it? Oops, yeah, it is. So that was an important conclusion. I leave it there for you to look at it for a second. Okay. And then I guess I can just move on. I don't need to clean the board right now. Then we... Alright, let's plot that guy. So our plot for that function is going to turn like that. If you don't know how that curvature is going up or down, just give it another point. So this was our point 1 that we fed to the function. This was the second point that got us here. And the third point, for instance, you can choose anywhere between 0 to L over 2, for example, L over 4 maybe. Put this number back into this function, and then find what m of L over 4 is, and then show it at that point. So your curvature has to pass through those 3 points. Okay, this is, I guess, yeah, that would work. And then what else? The other, and then, okay, so for the second part of the curve, we do the same kind of derivation. Oops. Where is the... I'm trying to erase it. Give me a second. Alright. Errands. Oh, do we need that? No. Okay. Well, really, I don't even need to derive that. You gotta know that, well, it's a symmetric case, and the loading is symmetric, and the moment has to end up at 0. You don't even need to go and find this curve. Like, I'm just showing it just to prove one little point over there. Okay, so assume that we don't know that right now. I just want you to note the change of the coordinate system that we made in order to find that function, remember? So for the second one, I'm going to integrate that guy to find my second moment. By second moment, I mean the one that is going to be plotted right there. Okay, so Vx is so mx for the right hand side is going to be integral of that yellow equation up there, w naught over L x2 minus w naught x, again dx. Okay, that is going to give alright, here's so that's whatever that gave. So we are putting we know that at x equal to 0 the magnitude is known, so we gotta find the magnitude here, as I said, which is x equal to L over 2, not L. We remember we brought we essentially shifted to our coordinate system to the right side, so that's why I just want to point out. So I use L over 2 here, put in this function, that guy, this one, and it turns out so it has to come up 0, right? So if you calculate this one term, you will find that actually this is 0, and then your plot has to go that way. So see, now what is the maximum of your moment? This guy. Another observation which might help you. Let me go up to maybe green. Okay, one observation to make here. So the derivative dm over dx, so the slope here is 0, right? The slope is 0, so basically v is 0. I mentioned that before.